Hello everyone, welcome to my video blog. In this video I will show you my experiment with doing a little bit of smooth scrolling for the Commander 16. So I will walk you a little bit through the code and then I will show you how the result looks like. So what you're seeing is a little program written in C for the KickC compiler, and to use the KickC compiler for the Commander 16, you need to start with a pragma statement. You need to do target CX16, and that way you can use the Commander 16. And also you can include the CX16 include file and the verlib include file, and then you have a whole bunch of tools to work with the Commander 16. So they're quite useful, and I really like KickC as a compiler. I also use some other include files here for some more standard type of things. Well, besides this one, this is to support the CPU. But I also want to write to the console, do some standard settings and be able to deal with strings. Below I also included two of my own libraries. These libraries I use basically to just set up the screen, so the scrolling magic is not in there. And I also use one of them to clear the screen. So there's a whole bunch of defines that I set up for this little demo. First the true define, I'm sure it's already defined standard somewhere in the KickC compiler, but I didn't find it yet, so yeah, I created my own true. So then there's another define to change the scroll speed of the little demo, and this is being used in the code. So I don't need to find the exact place in the code where to update the scroll speed. Then I have a bunch of variables that define the screen size, and these are being used by the KickC library to set up the screen. So the important part is when I'm scrolling, I'm updating the screen area, but I'm not updating the visible screen area. I'm updating outside of the screen area. So here I define the screen height to be 30 characters, but the screen memory height is 40 characters. To get some extra screen memory to work in, which is off screen, so you don't see the flickering when the new line is updated. Actually I only need an extra line, but I was lazy, so I just put in 10 extra lines. Then below here we got some variables. There's tons of variables in the program, of course. These are special ones, these are volatile. Why are they volatile? Because they're shared between the interrupt and the main program. And if they're not volatile, they're not really shared. So then you will not see the change you made in the interrupt to the variable in the main program, and the other way around. So here's the interrupt. In the interrupt I more or less just update a scroll counter and a scroll counter helper. And the scroll counter I use to write to the Vera variables, the low one and the high one, for the vScroll register. So the vScroll register, if you just write in it, the screen will scroll. And there's a low byte and a high byte. I calculate the low byte and the high byte here by some C magic. Here's a little interesting tidbit on the KickC compiler. I want to shift 8 bits, but for some reason I could only shift 7 bits, so instead I am shifting 4 bits twice. I'm sure there's going to be a better solution for that one. And at the end of the interrupt, thanks to a lot of help from the Commander 16 forum, I'm jumping to the old IRQ factor, and we should be able to scan the keyboard and so on. So that's the interrupt. Then we go into the main, or the initialize section for the main. So here I basically set up the screen in my KickC library. I clear the front and the back in my screen library, and then I basically read the old IRQ factor and I put it in this variable. I get it from the kernel IRQ. Then I disable the interrupt. I set the interrupt, I initialize it here. I point it to my interrupt and I say I only want to do a vsync, and then I enable the interrupt again. then I'm in my main code here. And in the main code, I of course first call the init, which we just talked about, and I do a forever loop here by doing while true. And in there, if I detect that the scroll draw line flag is 1, this is set in the interrupt. When it detects you have scrolled 8 pixels, then it's time to draw in the screen memory a new line. So here we draw a new line. Basically, we're getting the I position of the line from the interrupt. We have this variable called scroll row index. So which row on the screen needs to be updated, and this changes all the time because more or less we're doing infinite scrolling, and we're only changing the line that is outside of the screen, just on the bottom of the screen but outside of the view. Also, we're copying the scroll counter in this variable C because we want to put something on the screen that is new, so otherwise we don't see it scrolling. And we just hardcode the color. We set the address, the Vero address, to bank 0, and then we set the high byte of the address to Y and the low byte to 0. And then we just fill in the whole line with basically the character we just selected from the scroll counter, and then the color we hard coded. And this is basically 80 bytes of data. First you always have the character, and then you always got the color. And when you're done with that, you set we set the scroll draw line flag to 0, because the next time it comes in the loop, it doesn't trigger on this. It should only trigger on this when the interrupt sets it. So that's the whole program. Let's run it and let's see what happens. Okay, it's running. It's a little bit glitchy, but it's sort of smooth scrolling. Let me make the scroll speed 1, so I can see it a little bit better. Here, like that. And now you see a little bit better that it's smooth scrolling, and not just scrolling whole characters. It's still a little bit of glitchy there. I don't know exactly where the glitch is. Maybe the code for updating the extra line is very slow, and therefore it doesn't always get the next vertical sync, so to say. But that's something I need to figure out, and yeah, that's it really for this little experiment that I'm doing. If you have any comments or suggestions, please write them in the comment on YouTube. Or if you're interested in more of the Commander 16, just visit their website. Don't forget to press the like button if you like the video. And thank you, and see you next time. Bye!